Section 5.1, question number 8. Find the dimensions of a rectangular corral split into two pins of the same size, producing the greatest possible enclosed area given 300 feet of fencing. So we have 300 feet of fencing. We know that fencing is basically represents the perimeter of the shape. So we want to find the perimeter of the shape that I highlighted, which means I'm going to add all of the sides. So I have W plus W plus W plus L plus L. This is equal to 300. In other words, 3W plus 2L is equal to 300. I'm going to say this is equation number 1. Now, I know that I will need to have the greatest possible enclosed area. So I must use the area. The area of any rectangular shape is length times width. Notice how my two equations have two variables. So in order to solve, we would need to eliminate one of these variables. So what I can do, I can take equation number 1, solve for L in terms of W, and then replace it or place it into equation number 2. So from equation number 1, I know that 2L is equal to 300 minus 3W, but I want only 1L, so I will divide by 2. So I will have 300 divided by 2 minus 3 over 2W. And that is simplified is going to be 150 minus 3 over 2W. This is equation number 3. Now we're going to put equation number 3 into 2, sorry. So you'll have the area is equal to 150 minus 3 over 2W times W. So I removed L, replaced its value in there. Now we can distribute the W inside, so we know the area is equal to 150W minus 3 over 2W squared. This is quadratic. I'm just going to rearrange the terms. So area is equal to negative 3 over 2W squared minus 150W. Notice how this is quadratic. A is equal to negative 3 over 2, and B is equal to negative plus 150, positive 150. Plus 150. So now, in order to maximize the area, we're going to find the vertex. The vertex in this case is H and K. H is the same as the width because that is the variable I'm using in my equation. And then K is going to be the area. So I'm just interested in H. So H is equal to negative B over 2A. Also, that is the width, W. This is equal to negative B over 2A. That is positive, by the way. So it's going to be negative 150 over 2 times negative 3 over 2. Notice how I can cancel this 2 with that 2, and the negative with the negative. 150 divided by 3 is going to give us the width, which is 50. And the measure is in feet. So 50 feet for the width. Now to find the length, I know that the length from equation number 3 is equal to 150 minus 3 over 2W. So the length is 150 minus 3 over 2 times 50. Divide 50 by 2, you get 25 times 3 is 75. So the length is equal to 150 minus 75, which is equal to 75 feet. And that's what we need. That is the length, and that is the width. If you need the area, you multiply length times width using equation number 2, but it's not required in this question.